Let's start by understanding what a signal is. A signal is like a messenger that carries information by changing something over time. These changes can happen in many ways. Air pressure, which changes in air pressure, create the sounds you hear, like someone talking or music playing. Electric voltage. Changes in voltage allows radios and other devices to work. Radio waves, changes in electromagnetic waves, are picked up by antennas to bring sounds to your radio. Even though these signals are very different in real life, we can draw them in a similar way. So imagine using this graph here. The up and down line, vertical, shows how strong the signal is. The left to right line, which is horizontal, shows how time passes. For example, in this picture, I draw the graph of very simple sound called audio tone. This wave moves up and down smoothly, creating shape called a sine wave. This is what the sound of single beep or tone would look like. Now let's imagine a radio station wants to send this sound to listeners. How does it do that? A radio station uses something called a carrier signal to send sounds through the air. The carrier signal is another wave, as you can see here. It looks similar to the sine wave of the audio tone, but there is one key difference. Carrier wave moves much faster. So we have two signals. The sound we want to send, which is audio signal, and the wave that carries it, which is carrier signal. But these two waves are separate right now. How do we combine them so the carrier wave can deliver the audio signal to radios? The AM in AM radio stands for amplitude modulation. Now let's break that down. Amplitude means how tall or strong the wave is, its height. Modulation means changing something to add information. In amplitude modulation, we change the height of the carrier wave to match the audio wave. When the audio wave is strong, the carrier wave also becomes taller. When the audio wave is weak, the carrier wave gets shorter. This process creates a new wave called modulated signal, as you can see here. Now let's take a closer look at this modulated signal. You can see here. Now you can see the distance between the wave peaks and troughs stays the same as the carrier wave in this picture. This shows it's still the same carrier wave. Now you can look at the height of the wave's peaks. They have changed to match the shape of the audio tone from our earlier lecture. So it's like the audio signal is riding on the carrier wave. This is how AM radio sends sound waves through the air. But what about real sounds? So far we have used a simple sound, a single tone as an example. But the real life sounds like people talking or band playing music are much more complicated. Now you can see here what a real audio signal looks like. Even though it's more complex, the same rules apply. When we modulate this signal onto a carrier, the carrier wave changes its height to match the audio signal's shape. When you listen to the radio, your device performs a process called demodulation. This means it takes modulated wave and removes the carrier signal. What's left in the original wave? The music, voice, or sound you hear. So think of it like peeling a sticker of a package. The package, which is carrier wave, helps deliver the contents. Once it arrives, you put it away to reveal what's inside, which is the audio signal. Why do we need a carrier signal? So you might be wondering, why not just send the audio signal by itself? The answer has to do with how radio waves travel. The audio signal itself doesn't have enough energy to travel far, and the carrier wave acts like a booster, making it possible to send the audio signal over long distances. Now you know the very basics of AM radio, but we are just getting started. In the next lecture, we will also answer more questions. How do we pick the right carrier wave frequency? Are there other types of modulations beside AM? How can we use computers to work with signals? Stay tuned as we dive deeper into the exciting world of radio waves and signal processing. I'm Tayfun and I'm waiting you in next lecture.